Hello everybody, in this lecture we will be solving 1995 IMO problem number 5. Here is a view of this problem. Let ABCDEF be a convex hexagon with AB equals BC equals CD and DE equals EF equals FA. So I have provided a simple sketch of this hexagon, and I have clearly marked with decorations on the equal side lengths, as you can see here in this picture. We are also told that angle BCD and angle EFA both measure 60 degrees. Suppose also that G and H are points in the interior of the hexagon, as you can see in my drawing, such that AGB and DHE are both equal to 120 degrees. So these angles are equal, and they are equal to 120 degrees each. Finally, we would like to show that AG plus GB plus GH plus DH plus HE is greater than or equal to CF. So let's start by making a few observations. So first of all, we notice that this is 60 degrees, so therefore triangle CDB is not only isosceles but also equilateral. In a similar way, if I connect E and A, I also realize that EA is equal to FA and FE because you have an equilateral triangle. Next, we just realize that a quadrilateral ABDE is a kite, and as a result, if I connect line segment BE like that, we would have two congruent triangles, namely triangle BDE and triangle BAE, as you can see clearly on the picture. Obviously BD is equal to BA, DE is equal to AE, and they both share a side length BE. So obviously these two triangles are congruent triangles. From now on, I will consider BE as my axis of symmetry, and I will do a couple of reflections here across this axis of symmetry. First of all, I will reflect C across BE, and so this reflection, we know how to reflect stuff. So this distance here will be equal to that distance, so that's the point C prime. And secondly, and this is a 90-degree angle here, and secondly, I will also reflect F across BE as well. So if I drop a perpendicular here, so that those distances, so these are 90 degrees. So F prime would be somewhere here. And finally, when I connect C prime and F prime, like this, okay, I claim that C prime F prime is simply equal to CF. Moreover, we can say further that the two will intersect on the axis of symmetry, right? CF and C prime F prime. Let me write that down. CF intersection C prime F prime. Let's call it X. The point X is on, so X is here somewhere. X is on BE. And the reason is clear. You can think of the axis of symmetry BE like a mirror. So on the one end you have the line segment CF, and because we have reflected C across to C prime and F across to F prime, we would have a bunch of congruent triangles. For instance, if I mark this point as Y and this point here as Z, it is obvious that CYX, triangle CYX, is congruent to triangle C prime YX. And in a similar way, triangle F prime ZX, F prime ZX is congruent to triangle FZX, FZX. And as a result, CXF is collinear implying that C prime X F prime will also be collinear. CXF being collinear suggests that these two angles are vertical angles, and after reflection those angles will be preserved, those two angles, and as a result C prime X F prime is collinear. So as a result C prime X F prime is collinear. Now I claim that the sum on the left hand side can be expressed alternatively in the following way. So let's start with the following observation. So notice that because of the symmetry axis, BD and BA are symmetric. So in that sense, D is a reflection of A across that symmetry axis, or A is a reflection of D across the symmetry axis. So as a result, I claim that, well, first of all, BC prime is equal to BC, but BD is also equal to BD prime. So as a result, we preserve the equilateral triangle. So therefore, triangle BC prime A, this triangle is an equilateral triangle. Similarly, we just realized that ZF prime D is also ZF prime, not Z, sorry, E. So this point here, sorry, E, not this point, this point. Let me rewrite that. E F prime D is also an equilateral triangle, clearly, right? F is reflected across the axis of symmetry, so E F prime is equal to E F. In a similar way, A is reflected across the axis of symmetry, so D is nothing but A prime. So as a result, this is also F prime D is nothing but AF. So therefore, you have another equilateral triangle here. So now, if we combine all these things, so first of all, let's go back again. So CF is equal to, we established it's the same as C prime F prime. So the right hand side is replaced with C prime F prime. Now let's have a look at every single one of these lengths on the left hand side of the inequality, and let's try to express them in terms of the new construction that we have here. So let's start by doing the following drawing. I will just build a new equilateral triangle on such that one side of that new triangle will be on BG. Let me go ahead and do that, like that, I guess. And then let's call this point as M. I claim that GM and C prime are collinear. And first of all, let's make a couple of observations. So firstly, we have an equilateral triangle here. So BM, let's move that shape a little bit. So I did build on BG, I erected an equilateral triangle. So triangle BGM is equilateral. Furthermore, I claim that angle GBA is equal to angle C prime BM. Angle C prime BM, and this is obvious because this whole angle here, C prime BA, is 60 degrees, but this angle also is 60 degrees. As a result, the difference, removing that little angle MBA from both of these angles, we will have this desired result. So secondly, we realize that BC prime is simply equal to BA, and finally by construction BG is equal to BM. So combining these three by side angle side, we can conclude that triangle BMC prime is in fact congruent to triangle BMC prime BGA. As a result, this would imply that GA is in fact equal to C prime M. But then we also already established that we have established that BG is equal to BM as well, but that's also equal to MG. So that's number one, that's number two. So far I have handled this one, number one, and I have also handled number two. So now next one is GH. I will keep GH intact, so I won't make any change. Next will be DH and HE. I will use the same strategy, and I will build an equilateral triangle on our triangle on the side length HE. So this triangle would look like, yeah, I think it would look like this. And let's connect with this point as well. Let's call this new point as N because it's equilateral. So we have an equilateral triangle here. And so let me write that down. So triangle, so we build a new triangle. So not only BGM, but also triangle EHN are both built equilateral. So I specially constructed them. So as a result, like we did previously, it's not too hard to show that triangle DHE is congruent to triangle F prime and E, like we did here earlier. You can easily chase some angles. For example, we know that this angle here is 60 degrees, that angle is 60 degrees, meaning the remaining angles are equal to each other. So therefore, this little angle opening here is equal to this opening here. And obviously, FE is equal to DE. And finally, HE is equal to NE, so we are done. So it establishes the congruence of these two triangles. But the congruence of these two triangles would imply that, now let's stitch the pieces together. This would imply that DH is simply equal to F prime N. And finally, it also implies that HE is equal to NH, and we're done. So we can call this one as 4, and that one as 5. So go back to the picture, 4 here and 5 here. And finally, we can add up these and making sure that this one is intact. So we can replace AG with C prime M. So therefore, what I'm claiming is that the left-hand side, let's write everything here. So the left-hand side would become C prime M plus MG plus GH plus HN plus NF prime. So let me, so you can see it's NF prime. And we need to show this is greater than or equal to C prime F prime. But it is obvious, right? Because C prime F prime is a straight line between the points C prime and F prime versus the left-hand side. Starting from point C prime, you trace out the following line. In fact, let's make it slightly thinner. Okay, good. So we are tracing out CM, then MG, then MGH, going to NH, and finally NF prime. Obviously, the straight line between C prime and F prime will be longer than the addition of these line segments, which is not a straight line, right? So therefore, it establishes the desired inequality. And I hope you enjoyed this solution, and looking forward to see you guys in our next video.